In the club too. Steve, in the club too.
And the club?
Yeah.
So, welcome everybody. This is Dallas Personal Robotics Group. This is our monthly membership meeting. We meet here, usually in this room, every month on the second Saturday at noon. And we typically do some sort of a presentation or some cool demos like this. Or we might be having a contest. So a couple times a year we have contests here as well on this date. So today I'm going to be taking you through an introduction to the ESP8266. I had an idea for a project that was inspired by another member that was doing some work with some LED strips to make a LED sign. And so when he started showing me some of his work, I thought, hey, that's a great idea, except I want to be able to actually change the message, modify the properties of the sign from wherever I'm at, whether that's on my home network, or if it's a business, I'd like a business owner to be able to modify that so they're not having to reflash every time. So what I wanted to do was actually implement a REST API in an ESP8266, a little web server on this little chip. So first I want to just talk a little bit about the ESP8266 and the configuration that I have here. So I'm going to switch to this camera. Open out of this view. Okay. So this particular board is from Adafruit. It is the ESP8266 breakout board. This particular board costs about $10, so it's not very expensive at all. It has built in the Wi-Fi stack on it. It's also a simple microcontroller. It runs at 80 megahertz, has 4 megabytes of flash memory. So you can do other things with the flash other than just put the code in there. You can also save files or serve up web pages or those kind of things. The configuration that I have here, this is a 3.3 logic, 3.3 volt logic on this particular board. So along with this board, I've also got a small level shifter here. I don't know if you guys can see that.
So it's not 5 volt tolerant?
It's not 5 volt tolerant.
Okay.
Yeah. The pins I'm using are not. Anyways, there's a couple that are. But this is just another. I don't know if this glare here is going to cause a problem. Let me turn this light down. There we go.
So you said that the first board is a breakout board. Did you have to put something on the breakout board, or it already came with everything?
It already came with everything, right? So basically, all I did was connect the pins that you see here. So I've got power and ground. Over here, I've got just a 5 volt, 20 amp power supply. This is just something that I have on my bench at home. I also will typically use an actual power supply that's got current limiting and has all the features that you would have on normal. But when I'm moving around, this is a lot easier to carry with me. I do have a capacitor on here. Yeah, but I do have a capacitor on here just for smoothing out the voltage. And then otherwise, I'm just wiring up the power and ground, the 5 volts, to this. The regulator on board drops it down to the 3.3 that the ESP8266 needs. And then I've got a couple other pins here. These are the SPI 2 pins that I'm using to actually communicate with the LED strip. For the LED strip, this is also from Adafruit. It's a dot star strip. And I've got 2 different strips here. They're just daisy chained together. One of them has 30 LEDs on it, the other one's got 60. And I've got links to these parts for all the parts that I used at the end of the presentation, so you guys can go check those out if you want to try them out. Any other questions on the hardware? It's pretty
So
simple.
What goes through the level shifter? Is that a communication line?
Yeah, these are SPI communication, so it's a clock and a data line. And it's coming out of here at 3.3 volts. And it's going into the level shifter and then shifting up to 5 volts. These dot star strips do expect 5 volt logic.
So the dot stars are is each one addressable?
Each one is individually addressable, yes. Yeah. All right.
Well, yeah, I mean, you have to send the whole stream, right? You fill one and then it starts filtering for the next one or whatever, right?
Well, you
24
can
bits.
set it, and as long as you don't change it, it just keeps driving it whatever the last
Right,
time you set
right.
it was. Yeah.
So it looks like those strips are what, about $10 a foot maybe? 30 bucks
yeah.
a meter?
Yeah, about 30 bucks a meter. They're a little expensive on Adafruit, the dot star strips. You can do this with any of the 8050 LEDs, any of the addressable LEDs. I just happen to have a couple of these dot star from a while back that I ordered, so I decided to use them rather than buy new ones.
Yeah, those 80, sorry. Oh, well, that's minor. I'll shut up. I thought the 8050s are the ones that are real critical on timing. But then there's another group that's the ones that are
Yeah,
SPI
these-
and
you're right.
real easy.
These are the real easy
Okay,
version,
good
whatever
to
they
know.
are.
Okay.
I'm a software developer, not really electronics.
Okay. That's okay.
The hard ones just have a single wire, right? They just have timing.
Yeah.
You're right, it would be one wire, that's
Right,
right.
one wire.
Whereas the
This
easy
requires
one
two.
has a clock that
Right.
makes it easy.
Yeah.
All right, so first thing, this is what we're going to talk about. I'm going to talk to you just a little bit about SSL fundamentals. This is the secure socket layer. So anytime you're out on the internet, you're going to a commercial website of any kind, you'll see the little lock symbol in the browser, and that means that that site's using a SSL certificate, which encrypts the communication between your client device and the server, so that somebody else that's listening to traffic on the network can't actually intercept your communications or perform man-in-the-middle attack or do anything like that. So I just wanted to tell you, show you a little bit about SSL fundamentals, how that handshake gets set up, and how we trade secrets in order to establish that communication. This is not very technical, it's a high-level view, but I hope to, when you're leaving today, you have a better understanding of how that works if you are unfamiliar with it. Then I'm going to talk to you just a little bit about the code that's required to get this LED strip, right? Because this is a microcontroller in addition to a Wi-Fi controller. And so the first thing that we're going to do is just set up the LED strip to show that, okay, our MCU here is actually communicating and properly doing things with this LED strip. And then from there, we're going to, I'll show you how to set up the SSL server and get some simple request routing so that we can actually tell it, hey, I want to send or get some information from this device, and I can set up different routes so that I can ask different kinds of questions. So then we're going to implement both a get and a post using JSON to serialize our requests. Often whenever you're working with a web server or an API, when you send an object or any kind of a data as the request, or any response that you get back needs to be serialized into some sort of a commonly understood language. And today, mostly what people are using is JSON and REST APIs. So it comes back in a well-known format called JSON. And so I'll show you how to use JSON with the Arduino frameworks. And then another kind of requirement that I had in my project was actually being able to save and load configuration. So whenever you decide to use this kind of a thing, you may want to connect to the Wi-Fi here. This can act as both a station where you can set it up as an access point so that things can connect to it, but you can also have this thing connect to a Wi-Fi, like the DMS Wi-Fi here. And so I'll show you how we're going to use configuration to actually store those settings so that I don't have to change the settings every time I plug it in and unplug it. It won't lose its settings. And this is going to use the flash, onboard flash, to actually save that configuration in the file system. And then last, I'm going to add some basic authentication to your API so that not just anybody can control your device. And that's kind of where this presentation is going to end. But then I'll demo the actual project that I built using these same exact techniques with the sign and other things. And I've also got some sample code in C#.net in case you're interested in actually writing your own client that can communicate to your device. REST APIs are typically used for computer-to-computer communications, right? You have this website might have a service that's running and it needs to communicate with another service, and so you end up implementing these REST APIs so that the two can talk back and forth. And so in order to do that, you always have a client and a server piece. And so this is going to be our server, even though it's acting as a client on the network because we're just connecting to the Wi-Fi. And then I'll show you actually how to implement a client in order to control it. Any questions on the agenda? Yeah.
So do you mean that right now it's a client on the DMS access point, but anybody else that logs into that wants to talk to this, it is acting as a server for them?
That's right, for them. Yeah. All right, so let's talk about SSL. This is a basic scenario that you guys should all be familiar with. You're on a web page, you got your browser open, and you want to go to some website, someplace. And so you issue a request basically to go to that website. That goes out and queries DNS. So DNS is the domain naming system, which allows you to associate some name like google.com or bing.com to the IP address that the server is listening on. Because in the end, the internet really is just a series of IP addresses, and you have to tell it what address you're going to. But people don't remember numbers and sequences of numbers very well. It's much easier to associate names, so we set up a DNS entry. After that, it loads the website. And then we're going to request an SSL connection from the website host, right? So it knows that we're trying to communicate over a secure connection. And so the SSL host is going to respond with an SSL certificate. And that is the public key. There's a public and a private key set, or key pair, that SSL certificates will have. And so it's sending you the public key to start that communication. Once you have that, you can use that public key to actually create a secure connection and encrypt your data using that public key. So all the rest of the communication is going to use that public cert that you receive from the host to actually encrypt and communicate back and forth. So now everything that we talk about is going to be encrypted using that public key. Only the server has its private key. So only the server is going to be able to actually know what the messages mean and be able to respond appropriately.
And the client has a private key also. Each one has to have both the public and their own private.
No, the client is simply using the public key, and it's encrypting and decrypting with that same public key. The server uses its private key to decrypt and encrypt everything. So the two have keys that correspond. So I can encrypt with the public key and send it to you. You have the private key, you can decrypt it. If you only have the public key, you can encrypt it with the public key, and I can decrypt it with the private key.
So what keeps me from, I think I know the answer, but what keeps me from intercepting that key that is sent by that request and then generating responses as a man in the middle?
As a man in the middle?
Yeah.
Well,
Firewalls. Basically firewalls, another preventive measures, right? Because ultimately, if you're sending that over, like, you know, that's how the hacking works, right? Like if you're sending it over and it's just and it's on the public, and you manage to, you know, do a, what's it called, like a phishing attack, and you have some kind of credentials or something like that, then you can intercept it. Otherwise, you'd have to know exactly where that is. You have to like dig into the IP address, and then you're pulling it from, you know, the desktop or
Right.
something like that, because the guy's already got the public.
So
IP.
once you go through this first portion, we actually are communicating using the IP address, so we're directly communicating.
Yeah.
And so when I send the request, and I get the SSL cert from the IP address that I'm communicating to, then it's a tunnel between the two of us, so we have a secure tunnel. And there's not any way that somebody can intercept and say, now you need to start talking to this third IP.
Somebody could intercept it. They were using like a sniffer outside your house, and you didn't have your Wi-Fi with a
Encrypted.
firewall,
Okay.
and then they would basically be taking it, but they would be coming from your IP address.
But even if they did that, if I understood it right, even if they were able to grab the packets that are in transit, because of the way that they're encrypted, only the endpoints can decrypt it.
Only
No.
endpoints are really.
Only one
encrypted.
only one endpoint can
One
decrypt it.
endpoint can decrypt.
Only the guy who's originally sending. He sends you the public
Public key.
Then
Yeah.
you're sending the information back, and he has a private encryption on that he can do it at his side, but you can't decrypt it.
So we've
on your
encrypted
side.
with his public key, and then it can only be decrypted with his private key.
Right. Yeah.
Steve, could you?
But you can.
I,
Can I jump in here even though I just walked in?
yeah,
I find an easier analogy is to understand two lock boxes. I want to send a secure message to you. I lock that message with my private key and send it to you. My public key is public. You look it up like in a phone book. But only my public key can decrypt something that was encrypted by my private key. So you know it came from me. That's the first piece of security. Couldn't have come from anybody else because nobody else has my private key. Now I put that in a box, and I lock that box with your public key. So now only you can unlock that box. So now I know in my communication with you that you know it had to come from me, and I know only you can get it. So even if you intercept a piece of that, you don't have both ends.
Yeah.
There's no way you can get both ends.
right.
So you described the the bidirectional version of it. Yeah.
And the one part I didn't really touch on here, but it is important, is that there's two kinds of certs. There are certs that are created by a trusted third party we call a certificate authority. So there's some root authorities on the internet that everybody has agreed to trust. And when you are creating a website and you want to create, you have your own domain and you want to get a certificate to secure your website, you always have to go to a trusted certificate authority and make that certificate request so that they issue it and that it's signed through their chain of trust. So they have their own certificates that they've signed those certificates with, and there may be some intermediary certs in between. But eventually, at the bottom where your cert is, you should be able to do a verification of that cert to verify that it was trusted by a root authority and issued to you. And so if you're ever looking at the browser and you click on that lock, you can actually go view the cert and it'll tell you who that cert was issued to. And if you've ever been to a website where you see a big kind of warning right when you land on it, it says this is not trusted, it's most likely because that certificate was created as a self-signed cert. I can create certs all day long just at my desktop here, but nobody trusts my desktop. Right? The internet doesn't trust it. But for testing purposes, CA signed certs cost money most of the time, and it's also fairly difficult process, in time and effort. Whereas a self-signed cert, I can just issue an open SSL command and generate it in half a second and start using it. And so in this presentation, I will be using self-signed certs, but if you were trying to use this in any kind of a production or retail sense, you would not want to use self-signed. You would definitely want to use a CA signed cert. And there are ways to generate those for free through sites like Let's Encrypt. But most of the time, you know, if you're a big business and you need insurance and verification, and you would use, you know, an actual commercial server.
So you're saying blinky LEDs, not such a big deal, but.
Not
if they
such a
were
big deal.
Stoplights on major intersections.
Stoplights, or if this was doing something in a hospital, you would not want to.
Garage doors?
Maybe even
Garage
garage doors, because they can access your home, yeah.
Question I had, okay, so that there may be multiple connections to this web host, so each connection is gonna have a,
Each connection would have a similar tunnel.
right, but is
To
the,
each client.
okay, the question I have though, is the public key different for each connection?
No, the public key is the same public
It's the
key.
same.
But the certificate is a little bit different?
Generally, in that communication, it's not simply using the cert. There's also a nonce, and there's some other random things that the tunnel is created with, such that a second person with the same cert can't just pose as you,
Yeah.
right, as your
Okay.
client.
Well, yeah, something has to be unique there.
Yeah,
because
but
otherwise-
there is some unique signature that's generated between the client and the host when they create that tunnel.
And is the tunnel 5 and 6, is that what you call the tunnel?
The tunnel is 6.
Is that 6?
Yeah. 5 is just the response where I send you the cert, and 6 is the secure tunnel, where now we communicate back and forth to one another.
And I asked Dave previously, but David Anderson described, which was how my concept of the public-private, that it took a public and private from both ends. But you said that this is just a public from one end?
The public, yeah, the client that I'm using to communicate doesn't have a cert of its own. It's like when you go to anybody's normal website, you don't have to have some cert, right? They have to have the cert, and you use their public key as your end of that conversation to create a secure connection.
Okay, so you can decrypt from them with the public, and you encrypt with the public, and they decrypt with the private.
Yeah, I
Their
believe they can sign, your messages can be signed if you need to, but the idea is that you're creating this secure connection that is already, the tunnel itself is encrypted, so any traffic that you post onto it, you don't have to also encrypt, right? So.
Okay.
All right. So next we're gonna actually do some demo, and we're gonna write some code. I have no idea how well you guys can see this.
We can see that it's there.
Is there a way to
Let
make
me-
this bigger?
Let me do this.
You get some DPRG binoculars, just bring them with us.
Under settings, can you make it bigger?
That's much better.
Under better tool, you can make it bigger.
Oh, there you go.
Proper tool.
All right, you guys can see that?
Yep.
And I can probably make this bigger too.
Okay. Steve, just for clarification, will some of this code that you're showing now be in a GitHub?
All of this code that I'm going to show you will be in a GitHub.
All right, so it'll be available on the website?
Yeah.
All right, so if you don't be trying to copy this. Okay.
Yeah, don't worry about writing it down hastily.
Yeah.
I'm actually, as soon as I'm done with this presentation, I'm going to post all this up to the DPRG GitHub.
But you were in an Arduino tool, and you just pulled it up in Visual Studio so we could see it better.
Yeah, this is just, this is all Arduino, and so I'm going to compile and upload it with Arduino. It's exactly the same code. This is just a different tool, text editor. This is Visual Studio code. So the first thing I want to do is get the dot star strip working, and so make sure that this is power. All right, so I'm going to make sure this uploads first. So the code in order to make this work, this is Adafruits.star. You can install their libraries, and this library also has a requirement on SPI headers. As I mentioned, I've got two strips here. One of them has 30 LEDs, and the other one has 60, slightly denser, so a total of 90 pixels. And as far as the pins that I'm communicating over, the data pin I've got set as pin 14, and the clock pin I've got set as pin 16. And so the next line of code just creates a class instance of the Adafruit.star class object. And I pass in these pins and the number of pixels and the mode that I want to use. Then I create some variables that I'm going to use in the loop down below. In my setup code, I'm just turning on the serial, and then I'm starting the strip by calling begin and show. In the loop, what this is doing is we're basically just setting, every time we go through the loop, we're setting the pixel colors that we want. We're going to turn on the pixel at the head, and we're going to turn off the pixel at the tail. And by the head and the tail, I mean the idea of this particular LED strip, this is the test that Adafruit ships, so there's nothing crazy about this code. This just is kind of to show you that the strip is working. It's basically, it creates 10 LEDs and then moves them along like a snake. Yeah. And then, so we're just going to loop through, and we're going to have a 0 delay, so it goes as fast as it can go. If you pause about 20 milliseconds, that's equivalent to about 50 frames per second.
Is this like Dale's thing when you see yellow dots after we look at it?
No, this is not, well, you can also control the brightness. So I'm not gonna tell you to stare into the
Not gonna
LEDs.
blind us.
Yeah. And so this is the simple program. So let's go ahead and see if this will upload. The one thing you do have to do is, anytime you're uploading to these devices, there's two buttons on here, and you have to put it into an upload mode. And so you have to hold one button down, and while holding that, you select the other button, and it puts it into a mode that it can actually upload.
Are you uploading via Wi-Fi, or is there a connection?
Right, so I've got, that's a great question. I actually have a programming cable here. This has some headers on the bottom of it, and I'll probably show that.
It's kind of like the STM.
So it's just serial, old school, whatever, Arduino load.
Yeah, serial TTY. And so, because I'm powering it somewhere else, I'm not putting power in, but I've got ground and the send and receive on the serial.
RS-232.
Yeah, just
Yeah.
USB, yeah. And so the GPIO 0 and this reset button, in order to program it, you hold down the GPIO and then press the reset. And then this little
Just the right
LED,
time.
I don't know if you guys can see my mouse there, but this little LED is shining when it's in that correct mode. And then over here in Arduino, you will see that once it's able to make that connection, then it'll upload your sketch. All right.
Now,
Did that
Steve,
take, just out of curiosity, I kind of missed it. How long did it take to?
In Arduino, it's about 30 seconds. That's a little long. Yeah, it takes a little while. I've been experimenting with another IDE, and it's much faster. So I think it's more Arduino's ability to upload it.
I wonder if that's because it's writing 4 megabytes of flash. right?
Well, because, so the
That's
library
auto
is rather large, so that whole 8266 library is being uploaded along with your
Yeah.
minuscule 2K.
My little code, yeah.
Yeah.
okay, Steve, you might want to mention that you have to add the ESP8232 boards to the environment.
Yeah, that is true. When you're first working with these chips, in order to have support, you have to add this Adafruit Huzzah ESP8266. And so normally you just do this using the board manager in here. And you can just search for the ESP8266 and find the one from Adafruit, and then you get this. And you can also notice that there's a whole lot of other things in here where you can select the frequency, 80 or 160 megahertz, your upload speed, how much flash you want to use. This one is interesting, and we're going to talk about the file system in a later step. But when I first started working this, it was set to no spiffs. And so when I was trying to actually save or do anything in the configuration, it wasn't working at all until I realized I actually had to allocate something for the file system out of flash. And so you just have to set this to 1 megabit spiffs, and then it creates a 1 megabit file system in that flash so you can actually read and write files to. We'll talk about that in a little while. And I have not experimented with the rest of this, so I can't really tell you what they all do. There's a lot of stuff ESP8266 does. Huge community, tons of samples, and too much for me to go out and learn it all in such a short period of time. But basically, the important things are that you set the board and you set the spiffs. It's the flash file system that it's using. Yeah.
So I'm just wondering if you were doing development, I'm just thinking if that Adafruit.star, I guess you kind of really need that. I was thinking, could you do a lot of low-level development and then exclude that, or would that, you kind of need that?
If you're doing it through Arduino and using the Adafruit boards, you need that. But there's other ESP8266.
Because I was just trying to think, if I was building something where I was messing with hardware and I wanted a what did you call that, a compile download time that was hopefully a few seconds is what I live for. When it's 30, I feel myself aging. Well, because I iterate so many times. So for a developer like me, it's a killer to have that slow.
As I recall, that board also will support MicroPython.
Yeah. And that's got a lot of stuff built in it.
Yeah.
I guess the Pi library, PYB library.
Yeah. So I don't know that I set any brightness on this. Going to reboot it.
There it is.
So once you're done uploading it, down at the bottom it does say something along the lines of hard resetting via RTS pin. When you see that, it's done uploading, and then at that point you have to hit the reset button to take it out of that upload mode. And then your code will start executing. And so for everyone in the back, I'll hold it up a little bit. You should be able to see the LEDs nicely moving along. You can see that? Oh, okay. Now you can see it all night. All right. So let me open up the next step then. All right, so step 2, we're going to talk about the SSL pieces, where we're actually going to implement a basic secure server and test some, we're going to add a couple routes so that I can make a request and see that it's actually working, that my requests are making it there. So let me open this here. First thing I'm going to do is show you what's changed. Because what I wanted to do in this was just kind of show you the difference. So in order, on the left is the original code that we just uploaded. On the right is the new code that I'm adding for this particular step. So you can see we're adding a few new libraries: the ESP8266 Wi-Fi header, a Wi-Fi client header, and the ESP8266 web server secure header. And then I'm also adding this H file called certificate.h. And let me see if I can make this bigger. That easier to see?
Yep.
Yeah.
Okay. And then I create some defines. I should change this from my Wi-Fi to something else. DMS number. I was just thinking that in my head too. What's wrong? 109238. There we go. So I create a couple defines. This is just to define the Wi-Fi SSID on this network that we want to connect to, and the password. And then the next thing that we add after the .star, we're just adding this ESP8266 web server secure object, and we're creating a variable called server, and we're passing in 443. 443, for you guys that are not familiar, is the standard SSL servers port. So port 80 is for unsecured websites, and port 443 is the expected port that will be used. So if you don't specify a port, that's what it'll default to if you're talking HTTPS. And then I create a couple constants where I assign those SSID and password. And then in order to actually connect to the network, in the setup, what I'm doing is I'm calling Wi-Fi begin, and I'm passing in the SSID and password. And then I'm just waiting for the status to come back with a connected. And if it doesn't immediately connect, it'll wait a half a second, and then it'll try again. I've got some serial print statements just to show us that we've actually connected, and it comes back with whichever IP address this client was assigned. So on the network here, there is some dynamic DNS that's, or a DNS server. Yeah, server. That's not the word I'm talking about. It's assigning me the IP in any case. And then the next step is we're actually going to configure our SSL connection with the certificate. And in this case, I'm just passing in the server cert and the private key. And I'll show you that is in this certificate file. And so when you create a certificate, it has two parts. It's got the server piece, and you can see that this is in a pretty organized format, yeah. It's an encoded format. And then it's got the server key. So, and that's all that this file contains, is just that public key and the private key.
And this is a self-cert that you made for
This
your
is
web
a-
server.
Yeah, this is a self-signed cert. In order for you guys to know how to do that, I did put in a file called newcert.txt, and right here at the top line, I've got the syntax that you can use with OpenSSL
Nice.
to just create a new key. It creates two files, a cert.pem and a key.pem. They're text files with this exact text in it. You just copy and paste once you generate your own. Because you don't want to use mine, you don't want to use the default one unless you're just testing to make sure it's working that Adafruit gives. So in your own test, you should probably use your own certs just for your own security. All right.
But in the Arduino IDE, how would you do that? You just can't, there's no one.
In the Arduino IDE, you can do that. All you have to do is put more files into the same folder.
Oh,
The IDE itself doesn't really lend itself to adding extra files and doing all those things. But you can do it in any text editor, drop the header file, and then when you open your code, you'll see that it's got a second tab just automatically.
okay.
And so that's how you can add headers or additional, you can break it up into multiple files. The IDE itself is a little pain to do that. So. All right, so let me get back to the.
That was DHCP, is that what you're?
DHCP is, yeah. No, that's not the right word. There.
Learn how to do this. That looks really useful.
So you connect to the Wi-Fi, and then what did you do with the certificate there?
So I connect to the Wi-Fi, because that's just this device connecting to that Wi-Fi, and it doesn't require anything to do with the cert. The next part is I'm actually configuring my SSL server object. And so up here in the, when I created the object, I created the server and I said use port 443. But to this point, we haven't actually configured that server with any kind of certificate. We haven't told it what to do if it gets any requests. So that's what we're doing now.
So you're going to be a server on that network that you connect to?
That's right. So I'm going to make this device actually have some endpoint that's listening for incoming connections, which makes it an actual server. And so this line, 62 and 63, this is where we configure our certificates. And then what I'm going to do is actually configure my routes. And by routes, I mean when you make a request, it'll be something in the form on the browser like http:/, the website address or an IP address, / some path. And it's that path that is what the route is that I'm talking about. And so in this case, I'm just going to set up 3 routes. The first one is the default route, which means I just typed in the website and nothing else. So this is the root. And I'm going to, whenever I get requests for that, I want to go to this function called handle root. And then I've got one called /strip, which means I'm going to create one, the framework, so that I can control the strip. And then I'm going to call this handle strip function anytime I get a request that matches that route. And then when somebody passes something that I don't recognize, it's going to go to this on not found. So if you pass anything else, it's going to go to not found, and it's going to go to that function. And then I'm going to start the server, because at this point, the server has everything it needs to actually create that connection, or create that server endpoint. So it knows what ports it's listing on, it knows what certificate it's using to establish the communication, and it knows what paths or what routes that we're going to respond to. And so at that point, we can start the server.
And you had both a public and a private key?
In that certs.h file, yeah. The only thing that we're changing in the loop is a call to server.handleClient. So we have to actually poll the server to say, hey, did we get any requests? And we need to go handle those requests. Otherwise, if there's nothing, then it's just going to continue doing what it's doing here with the lights, with the strip. And then we're going to implement our 2 or 3 route controllers. So for this step, I'm just responding with a standard 200 OK. So when you're looking at how these computers communicate the HTTP protocol, whenever you make a successful request, it's going to respond with a well-known HTTP status code. And when everything is working, you get a 200 OK. If you hit a page that's not found, it's going to return a 404. If the application itself crashes and you have exception handling so you can catch that, then you would typically send something like a 503. But there's a whole bunch of different HTTP status codes that you can look up. When it's appropriate, you try to use the right codes. And then we're going to respond just with plain text. This is where you can tell what kind of content format I'm going to respond with. So in this case, I'm just responding with plain text. And I put in the path that I'm responding from and the message. So this is just one output string. I'm just kind of showing you that this came from the root and hello. And I've got the same thing with the strip so that we can actually test it and verify that this is working, that I can call either one and it's correctly routing to the right place. And so that's the rest of it. In the bottom, you can see I'm just creating this string that tells you, hey, you called this, I don't know what you're trying to do, but this path's not found. And so I put in some more information to help you debug maybe what your problem was. So let me upload this. Yeah.
Is that actually building files in a file system? In other words, is it building a file system with a root directory called / and putting an index.html file in?
This is not, no. This is all handled in memory. You know, I just provide the path, and it is responding on that path with whatever I do here. If
So
I,
basically, the path is just a symbol that doesn't actually represent a quote-unquote path.
that's right. Yeah, this is not using any kind of static file system or anything at this point. Yeah, you could serve static pages if you wanted to build up and upload static HTML pages. This does have a file system on it. You could actually respond.
But for this demo.
For this demo, we're not doing anything complicated, yeah.
Just sort of reuse it, the syntax or whatever you want to call it,
Right.
sharing it, whatever.
Okay, so let me upload this step. Start that, put this in upload mode. Start your clocks.
Have you tried the higher COM port rates?
This is at 115.2. I haven't really tried anything higher than that.
So it made a big difference on the.
It does work.
On the make.
Yeah, because I got another project I was doing, whatever
It's
the
configured.
nearly 1 million bought.
Yeah, it makes a huge difference.
Root is not Linux is root, but there's a sub-file system.
Yeah.
Regarding Ron's question, what does it? Do you have to worry about how many times you are downloading into the flash?
Yes, actually. I didn't. Sorry, I didn't hear that question.
Well, it wasn't
no,
a
I
question he
didn't.
asked, but he said he has to do a lot of.
Oh, no, I
retries.
was talking more about me dying and not the chip. No, I was talking about the amount of time, you know, if it takes me 10,000 times to iterate, you know, a development cycle, then
Right,
I
so-
gotta add that.
Yeah,
So
so
then the question is,
in
can you do
regards to
that?
that question, yes, this flash, if you read the spec from Adafruit, it has about effective 10,000 writes in that flash memory. So if it was Ron and he takes 10,000 times, he'd have to buy 2 chips, one for testing and development, and the other one to
It's like
actually use.
one a week, he's worn it out.
Sounds like what it
I think those are before kind of you extremes get it too, like if you don't overstress the part in other ways, like.
It's
applying-
guaranteed.
Yeah, guaranteed.
that's
Yeah,
kind of-
you can probably go far more than 10,000.
Yeah.
So 2 weeks for one.
All right.
10,000, but I don't even know that anyone's actually worn one out or not, because
Yeah,
it broke so many times.
there's probably a factor of at least 2 in there, safety margin.
Yeah.
I got another question. Are there versions of the chip which don't have flash? Instead, it's just SRAM or DRAM, just for development purposes. You're not going to deploy it, just so that you can dump things into it and test it, simulate it.
Maybe.
Okay.
As far as I know, all the ESP8266 have some flash. I don't know about every variant though. The ones I've looked at have all had some.
And it might
type
have
of
to
flash.
do with just the speed of the fact that this is a slow serial interface. There might be some options with faster JTAG. Yeah, JTAG type stuff where it'd be just much quicker to download.
Sorry, look at that, 27.6 seconds. It's a run killer.
Yeah, it is. I didn't save my changes, so when I compiled it, I used the wrong user or SSID password, so doing it.
I'm just flabbergasted that we live in a time where professional developers bitch about 30 seconds.
I know.
Compile and download. Even to an embedded device.
No, those are upstairs.
Should go back to punch card.
Yeah,
So Steve, there's
go back
a,
to old 27th, right?
there's a way to set the Arduino IDE so that it knows you're editing in an external editor like code.
Oh, yeah?
And if you set it that way, then when you make the changes in code and save in code, the IDE automatically picks it up. You don't have to do what you just did.
I don't
How
think
do
I
you
ever
do
hit the
that?
save.
That may be too,
Yeah.
but I'm saying,
Carl, how do you do that?
Yeah.
I asked Google. No, there's a setting in there, I forget where it is.
It's what pull down thing and you go.
One of the pull down
click on
things,
something,
yeah, that's how I run it these days.
There's a setting somewhere.
And then you can use
I do all the editing in VS Code, and then I download to the chip and console debug log through Arduino. There's actually a nice, what's supposed to be a nice plugin for
There is.
Arduino for VS Code, but I couldn't get it to work on my,
It's called Platform IO, and I've been experimenting with it. It works great.
that's an even better one, but there's
Yes.
one before that.
Well, Platform IO is real cool.
Yeah.
I'm actually experimenting with that on the ESP32,
Nah.
and I've got a little web API working on that. I haven't got the secure part working yet, but just the basic non-secure one works great.
Nice.
But I've used the Platform IO. I'd never used it before, so it's,
That could be another presentation you can get.
yeah. All right, so now I'm going to reboot it, and we can follow along with the comments here. It should try to connect to the Wi-Fi, and hopefully I got the right password in this time. 102398.
So why isn't that the other?
So we're in a loop printing a dot every 500 milliseconds.
Yeah.
Attempting to connect.
And this better work, because I didn't bring my own.
Spot.
I didn't
So
bring
what-
any other hotspot.
We got phones you could use.
That's true.
Okay, so DM has member, you did that right. So those would be the things you could goof up, right? The wrong SSID or the wrong password.
Yeah.
Oh, Steve, is it member or members?
Member.
Member, okay.
Who came up with that?
So this is the exact one. Is it just me?
So this is the exact one.
So the 102.398, that's the one that you assigned to it, right?
No, that's the DMS password, right?
That's the DM.
That's the standard guest network.
Try this.
It's not the 109, whatever.
Oh, maybe it is. Is it 109.238?
Yeah, it's
Yeah,
one.
sure is.
There
Okay.
you go, 109.
10923.
But,
Like, I know it works because that one's working.
Steve, the SSID is now wrong.
Teamwork.
That's okay.
Teamwork
We'll get it
makes the
there.
dream work.
Must be used a lot in Microsoft.
No, I gotta stop.
Well, it's a more entertaining display.
That's right.
Do you feel life kind of draining out of you?
Oh, I definitely.
This is why the good Lord made a cup of coffee. That's what a
Right.
cup of coffee is for. I figure 30 a day, maybe. Steve, I missed the part where you said how much this card is.
$10.
How cool is that?
But the shipping's another 10, so you gotta.
Buy in bulk.
From Adafruit, you could probably get like the
You can-
Chinese equivalent for $5.
Yeah, you can
Yeah.
get these ESP8266 chips almost anywhere. They're
I think on
very-
Amazon they had them, but yeah, then the wait time is a month or whatever.
Yeah, well, Chinese tariffs are probably getting harder to get, more expensive too. But
Yeah,
but
'cause-
Tanner's probably carries these things. You don't have to.
And then there's the newer version, the ESP32,
Yeah.
that's
Yeah.
got more oomph.
Oh,
Yeah.
More input, 2 cores.
Yeah.
Faster clock speed and everything.
And not that much more money either.
but it sucks more power.
Hey,
Alright.
Oh, that's a good question. How much power does this thing suck?
Oh, it's,
I know you got your 40 amp power supply there.
Yeah.
yeah.
So I did test that.
Mine-
I have no
Less
idea
than
what
2
that
milliamps,
is.
good.
Um,
Way less than 2.
It worked.
Did you already make a request to it?
I did ping you, I got it.
Yeah.
Hello from ESP.
Yeah, so, yeah, what you see here is anytime someone makes a request, the loop stops because it's trying to handle that request. And the reason it stops is because we're only working with a single core on this device. And so in the main loop, anytime it hits this handle client and there's a client request waiting, then it's actually got to go do that work and then come back. And it always takes, you'll see a second or so lag whenever that occurs.
So the dual core, really, if
So-
you're doing real-time stuff. it's
Yeah, you would have
good.
one dedicated to the Wi-Fi and one dedicated to whatever else you want to do.
Okay, and it's good about that.
It's good, it's great,
Okay, okay,
yeah. And
okay.
actually has free RTOS. You just load the free RTOS libraries and create a task, and then it does everything for you. But you could easily use Dave's
Okay.
libraries as well.
I want to add one thing here, Joe. If we go out, everybody's going to go out and buy I think it's an ESP32. You have to be careful because it comes in different flavors. There are 1-core ones, there are 2-core ones, and I think there's even a 4-core one. But if you just, if you get the El Cheapo board from China, it's probably going to be a single core. It'll be it'll be it'll say 32S. Okay, the ones that have multiple cores will say something like 32W room something or other. Okay, so I'm just saying that so that people don't get the wrong board.
Yep. All right, so this utility that I just loaded here, this is called Postman, and this just allows you, this is something you just download off the internet today. I've actually got two tools that I loaded up while you were talking. One of them is called Fiddler 4. This is an HTTP diagnostics tool. It's kind of a similar thing as if you hit the F12 or F11 on your browser and you get the developer tools. So you can see the network traffic and the HTTP request and response and the codes and all those kind of things. So it's good, you know, when you're looking at this, you can actually inspect all the information that's being passed for every request.
So it's just listening on the network to make this log?
That's right, and you can see that it gets everything that's on this particular VNet that we're connected to. And so there's a whole bunch of stuff happening. This is probably stuff my computer may be doing because I got a couple tools or whatever open. Yeah. So be careful what you see. But one of the things that I have this for is because HTTPS, of course, is encrypting the traffic. And so when you want to debug this kind of a thing, when you're working with HTTPS, you need to decrypt the traffic in order to actually make sure that it's working and that you can see what's going on. So this tool allows you to add, turn this option on to decrypt traffic, and what it's going to do, it's going to go down and download a whole bunch of certificates off the internet to trust. Like, so it puts all these things in your trusted root from Fiddler. It says, you know, when you're looking at it, it says don't do this, don't do this, don't do this. But it's just a developer tool to help with this kind of troubleshooting. But anyways, I have that running because what that allows me to do is connect to things that I don't trust. And so in this case, I'm going to craft a response to my web server, which is the ESP8266, using a self-signed cert. And normally, the browser would kick that back and say, hey, I don't trust this cert because there's no trusted chain, and so it would fail the request. But if you turn this thing on,
This site's, this 192.168.202.111, was your DHCP. The
Yes.
site security certificate is not trusted.
it's not trusted.
Exclamation.
That's right.
Isn't
Would
there
you
a
trust
browser
Steve?
thing that you can say go ahead anyway?
Yeah, there is. But in any case, I just do this so it makes my life easier. And so in order to test this, what I'm going to do, when Carl quit sending requests.
And what is this app here?
This one is called Postman. And so you can use this to craft your REST calls, the HTTP calls, and you can set the headers and you can set the body. If you're doing a post, you want to send some data, all those kind of things. So it's just a nice tool to not have to go write more code to send the request. This does all that for you. And so all I'm doing here, I'm going to do a GET. So you can see there's a lot of different types of requests that I can make. The two that we're going to be talking about today are the GET and the POST. The GET is a standard action or request type where we're just trying to get a response. We're hitting this page and give me whatever you have as a response. And so whenever you think about I want to read or write data, you would use the get to read the data, and you would use a post or a put. There's two different types, but the post is what I'll be using today to post the data and actually write the data back to the device. But in this sample, we're just looking at the get right now, because that's all I've implemented. So when I make this request,
I'm confused about that address. I thought it was 111.
oh, you know what? This is my home address. You're right.
It's 202.111.
Let me get the right IP.
That's what's cool about Postman is when you sign in, it'll sync all of your requests up to the cloud, so you can go from device to device
Yeah.
and one laptop to another, and it keeps all your requests organized.
Should turn all this other stuff off.
What was this tool name?
Postman,
This is Postman.
Okay.
there's free level and a paid team level, and it has test runners, it has all kinds of stuff you can do with it.
So right now, I'm just sending in the address, so this should actually hit the root path that we programmed. So you can see that it got the request, and now it's trying to process it. It says, hey, I don't trust this thing yet. And then the response comes back and says, path root, hello from ESP8266 over HTTPS. So we've made a successful secure connection because we're talking on port 443, which means that the certificate handshake worked, and we've actually routed to our root controller, which is where we asked it to go. Now, if I want to try to get to the other controller, the strip controller, we just put that on as the path, and then we make that call again.
So the get would be just as if you were just typing that path into any old browser.
That's right.
But you can do other requests. What would you do in a browser to make a different request?
You would just change the path. So
Right.
let's say you had 4 different devices connected to this microcontroller, a humidity, a magnetometer, and something else.
It would be slash this.
You would say
that.
slash, temperature, slash humidity, slash whatever, and then you could create a different control handler for each of those things to go read from the correct sensor.
Right, I get that, but I'm asking about the get pull down, because in a normal browser, you just put slash strip, slash temperature, slash.
In the browser, it's going to be a get almost always.
Okay.
Unless you're on a web application where you're filling in a form,
Okay.
when you hit the send button, behind the scenes, their code is actually packaging up your
Doing
form
other-
data
other
and doing a
code.
post.
Okay.
But you have to actually write that code. If you're just making simple curl requests or things like that, like this, you're just doing a get. Yeah.
So,
Oh, I felt myself aging a little bit, waiting for that thing to come back.
That's because someone else was
Wasn't
also
me.
making requests while I was doing that.
Steve.
I had to wait my turn.
So if you say send again, it should be lightning fast.
Well, it'll be not lightning fast, but it'll be as fast as it can be. Like it stops immediately, and then it takes a while,
Does
and then it
take-
responds.
To decrypt that, is that what's burning the time, or what's?
Honestly, I'm not sure. On this one, so far, they've always been slow. On the ESP32 tests I've done, very fast. So I'm not exactly sure why it takes as much time as it does, but all my tests, that's what I've seen. All right. So we've done that. Now I'm going to do, give me the info. I'm going to do some other path that it doesn't know anything about. And so this should come back with the 404 response. Say file not found. And we're using the file not found terminology because typically this would be talking about a file system and static pages.
Steve, should you highlight over on the Postman where the 404, the
Yep.
time response is?
Over here on the right where my mouse is, you can see the actual response. And it tells you
5
what,
seconds.
yeah, and how long that request took. Any questions on this so far? So you want to move on to the to the next part.
I just tried to find /Fred, and I got a file not found.
File not found, yeah. Okay.
I think so. That was the question, could you put a real value? This is just a public slash. It's almost exactly. There's kind of
All right, nobody come to my house and hack my network. That's y'all's password. I have to change it now.
It is memorialized forever on the DPRT video.
It'll be changed today. No worry. I meant to change it before I came here today.
Yeah.
It's not live, is it?
Okay. So the next step is we're going to actually add in some JSON serialization and show you how that we can not only do GET requests, but we can send it data through a POST request, so we can change the values. We can change how fast this moves, and we can also change the brightness of the LEDs. And that's what we're going to implement next using JSON to serialize and encode that data over the wire. All right, so the first thing, there's a project called Arduino JSON. Anyone use that before? So it's really very easy to use, and if you're doing any kind of a web-based project, I would recommend it as a way to do this rather than mucking about with manually creating JSON text strings and things. And so it's simple to use. You just add the header for Arduino JSON. I have a define called config size. This is basically how many bytes for the JSON document that I'm going to create, because this creates something called a document, and I say I want it to be 512 bytes. You can optimize this. My example here doesn't do very much in the way of bounds checking or anything, so a determined hacker can easily craft a big message that overflows these things. So I create this document. I'm creating a couple new global variables. One's called brightness and one's called speed. And I'm setting those defaults here, 50 and 100. And then nothing changes in the setup. In the loop, every time I go through, I'm going to delay, instead of 0 milliseconds, I'm going to delay whatever speed is set to. So I just made that small change there. And then in the root controller, I didn't change anything. On the handle strip controller, now I'm adding in similar things that we did for the not found. So we just kind of spaced out what information was sent, so you guys can see that. But then I'm adding a switch statement on the server method. So depending on whether I'm making a get or a post, I'm going to execute different code in this handler. On the get, what I'm going to do is actually clean the JSON document, because I'm reusing this object over and over, so I'm not having to recreate it or leak any memory like that. And then I'm creating the document with two properties. One's called speed, the other one's called brightness. And I'm just setting the values of each of those to the corresponding global setting, whatever that might be at the time. And then I'm going to serialize it. And there's a couple different methods. One's just called serialize JSON. The other one's serialize JSON pretty. So it formats it, looks a little nicer when you're debugging. But other than that, you know, if you don't care about formatting, you don't have to use the pretty one.
What's the penalty of using pretty?
It adds extra line feed, so it's slightly lower, not much. The output is just a string. The doc is the JSON document. So what we're doing is we're serializing what's in the document, and we're putting it, the serialized result into this string called output. And then I'm adding it to the message. And up at the top, I just created a string called message where I added all this other stuff to. So we're just kind of building up one big response. And then once we have that, then I'm going to return that. But you notice I send the 200 OK, but now I'm also telling you that, hey, this is in JSON format. And so the client, if they need to do anything special to handle formatting or deserialization, they can test and know that it's the right format. And then we just pass the output.
Up above, everything said message plus equal to appended, but here it just says message equal output.
Yeah, you're right.
Whoops.
Play.
Play.
Play,
Good catch. Good catch. Okay, and then on the post, so if we're trying to actually update our settings, the post basically, what we have to do is look in the document, whatever the client sends us on that post request, we're looking for something that's a speed, and we're looking for something that says brightness. So when I create my post request, I actually have to create a little body of text in this JSON format that has these properties. And so I create a couple strings with the things that I'm expecting to find. I deserialize the JSON, and so whatever I send is part of my body of my request, and I'll show you how we set this up in Postman. It's going to come through as argument 0. And so I'm going to take everything in argument 0 and I'm going to deserialize that into this JSON document. And if there's any errors, we're going to send back a 500 status code, which means that a server-side error occurred. And whatever the error was, we're going to send that back to them.
And that argument 0 is meant to fit in that buffer size that you specified.
Meant to fit in that buffer size, yeah. And then what I'm going to do is I'm actually going to look at this JSON document, and I'm going to say, if this document contains the speed property that I expect, then I'm going to save that off, right? So first thing you need to do is capture the variable, and then what I'm doing is I'm constraining it between 0 and 100, so they don't send something like 5,000 or whatever, it'd be too slow. And then I build some more message, and then the next thing I'm going to do, I'm going to check to see if they sent a brightness. There's nothing that says that I have to send both values every request. I can just send a post with just change the brightness or just change the speed, or I can do both. And so I don't want to assume that both of those things are going to be in the request, but if they are, I can handle them both in the same one request, or I can handle them individually. And if it doesn't find anything, it's just going to drop through anyways. And so then, after I build all this message up, again, I'm going to just respond with a 200 OK. But when it comes through, and again, like the brightness is constrained between 0 and 255, since these are global variables, I'm just updating the global variable. Now, if I run this code and we change the settings, and I unplug everything and plug it back in, whatever these settings are have never been persisted anywhere, so it's going to go back to the defaults. But for now, while it's running, we can just change this all we want. So let me upload this. Save this.
Also, the thing you were saying avoids having to push the buttons.
The what?
The thing, the download thing you were mentioning.
Yeah.
Like you not have to push the buttons.
I forget where it is.
No, that's right.
Next Tuesday.
That's right. No, I just,
But yeah, no, it's much more convenient because then you just
do it.
tell it the one file that you're working on, and then it reads the latest from the file system. It doesn't assume you have to reread everything. for the IDE. I want to try Steve's method, for example, because platform.io.
Yeah, works great.
Yeah.
It's different for sure, but it's faster.
I don't.
Yeah.
Was there any of the variants that are faster download times, anything using another interface or the ESPs?
Steve was saying platform.io is.
Oh, it's faster.
Yeah, it's
Much
faster.
Oh, okay.
All right, so now that's uploaded, so I'll reboot or reset it, and we should see it connect to the Wi-Fi again. All right, so now you see that it's picked up our new speed, so it's going much slower. If you look at the lights, it's moving around a lot slower, and the brightness is at whatever the default I said, I think 100 or something.
Nice.
So now, if I come back to the other one, Postman.
Either that or you sped up time.
That's right.
Yeah, your watch is running slower now.
No, you wouldn't notice. Certainly, because your brain's working, so.
All right, so in Postman, you can see that you've got a few things here: authorization, headers, body, some other stuff. The body is where we're actually going to put the settings in a JSON format that we want to include with our request. And so I've set the mode to post, and I've set the path to strip. And now what you do is you just have the open squiggly bracket, and JSON properties are set up as key value pairs. So you've got speed in quotes, a colon, and the value. In this case, it's an integer value, so you don't have to put quotes around it. And it'll deserialize as an integer. If it was a string that you were trying to send across, you'd want to put it in quotes. This is a very simple JSON. You can have all sorts of more complicated nesting, arrays, a bunch of stuff with JSON, but we're not messing with much of that in this demo. So I've got a speed and a brightness. And so what I'm going to do, right now it's set at 100, and I don't know who's making what request.
It's not me.
That Dave guy back there.
That's the, you just can't trust
Zero.
Is that a speed of 100 and a brightness of 50?
Yes, so you did the get. Yeah. So I'm going to change it by doing the post. So as it starts moving again.
That was me, sorry. Just exit the browser.
it's fun to play with the demo guy, isn't it?
Next time I will
This
do
is
it on
just
my
going-
Wi-Fi.
Carl, this is just going way too smooth.
So this is secure, it's doing two connections at the same time then?
Yeah, as many clients as
Okay.
want to connect to it. It's just serving any request that comes across.
Is there a setting in the server you could say only allow one connection at a time?
I believe there are. On the ESP32, there's a configuration when you're setting that up, and you can say how many concurrent connections. I think 7 is the limit for the default. I don't know what the ESP8266 default is, but it's probably something around the same thing.
Well, I think Dave might have broken it.
Yeah, Dave.
There it is.
All right, so now it's going a little faster and it's less bright because I dimmed it down to 25. So you can see that, that it actually took the request, took the new settings. If I change this back to get and I do the send, then we should get those values returned to us as we expect. So now you can see that it returns speed 50, brightness 25. If I go back to post, maybe we can do speed 0, brightness 255. Sorry, buddy. Somebody's doing it before me.
Or Clay, I mean, he could implement authentication on his ESP8266, so you have to log in, and it'll give you a token before, and then only people with tokens are allowed to send values.
Right.
And Dave doesn't get a token, because he's enjoying this too much.
There we go. So, and you can see in the serial monitor where I was actually printing out all those things, that we received the post with the new values. It shows you that we received 0 and 255. So I'm not sure if someone's making a request if I found a new bug, but I think you might be crashing it. Whatever you're, like I said, I didn't do a bunch of validation. And so if you don't have all the right commas in the right places, the right squiggly brackets,
For the JSON
yeah,
format.
it'll sometimes crash if you pass it in the wrong, because you do need to verify or validate some of that and wrap it up in some exception handling.
Well, when that file could be written by anyone, it could be another program running,
Yeah.
say, reading the joysticks. and-
Right. That's right. So, okay. So,
On the other requests that are causing us to pause, does the code write out anything to the COM port? I mean, could you see requests coming in or out?
Yeah.
Could you monitor that?
yeah, you should see on this serial output, every time we get a response or a connection, because I'm doing some serial writes through this cable to this monitor. So, all right, so the next step is configuration. Set. Sorry. There we go. All right, so in order to add support for configuration so that we can actually write our settings out that we want to the flash so that if I power it down and power it back up, it'll remember them, we have to add this file system header. So we add fs.h. I'm creating a structure called config, and this can be any custom configuration that you want. You can add a lot more properties to it. In this case, I just have the speed and the brightness, which are the two variables that we were using. I delete my two globals and I replace it with an instance of my config structure instead. That way I'm just working with one variable. During the setup, I'm going to add a function call called load configuration. And we'll look at that here in a minute, but that's just another private method that I implemented to actually read from our configuration. Some space change, comment change. In the loop, we update this to use the configuration delay speed rather than the global variable. Nothing changes in our handler there, except when we do the get, instead of returning the global variables, we're returning the config variable, varying to the same things. We have our bug. Fix that. Again, the only thing I'm changing here is just instead of using globals, I'm using the config, so that's not much different there. All right, in this post request, when I send in a new setting, the first thing I want to do is I update the setting in the config, but then I also save that out to my file system. So every time I make the request and I update it with new settings, I'm going to save it to the file system, to Flash. And so in order to do that, I also created a new method called saveConfig. and I pass in a constant file name and the config variable itself. If that succeeds, then I do a serial print that it was good, otherwise I throw an error. All right, so then here is the actual code that I created to read from the file system. This one just calls spiffs, and that's the file system object, the class object. It's a static. So I say begin, that turns it on. And if there is a file system there, it'll start using it. If there's not, then it's just going to return. Let's see. Or I'm sorry, the spiffs begin just starts the spiffs communication. This is where in the Arduino, remember I mentioned that you have to have that spiffs enabled, and that was this thing here, where you have spiffs 1 meg or no spiffs. By default, it was no spiffs, and that function would have failed right there. But
So basically partitions the flash, some for program and some for classes.
that's right. That's right. And so you have to have that enabled in order for this call to succeed. Otherwise, it's going to return. Then I'm going to look at the spiffs file system information. So it's going to go out and actually try and read that partition. And if it can find it, that's great. Otherwise, it has to go format that partition so it's useful. And so this code basically says if you don't find any spiffs info, or if I have a flag set that says just format it now, then I'm going to go ahead and format it. I added this flag so that I could reset it, just in case I bricked it in my tests. I could just say force format. So in that case, if it finds it's never been formatted before, it's going to go ahead and format it. Very simple call. Then I'm going to load my configuration. And again, this is another method. It's called load config. And I'm passing in the file name that I want to read and write to and the config. I created a method called initialize with default config. Let's see that used in a minute. Here's the load configuration. So here we're basically opening the file on the file system, what we call file name, in read mode. So the flag R there is for read. There's another one W for write. In this case, we're reading. Again, there's a little bit of error checking. This, I'm also just doing a little bit of kind of litmus test. Say, hey, if this file is larger than 1024 bytes, then there's a big problem because it should not ever be that big. That's just in case somebody's trying to do something weird. Then once I've read my configuration, let's see where that was. So I've opened and I've read into this config file variable. And so here I'm deserializing config file back into my doc object. And as long as there's no error, then we're going to continue. And again, this is just like the get operation where we're checking to see if we can find that property. So if it contains our delay speed, then we can set our config variable with that delay speed if it exists in the document. Same with the brightness. So we're going to check the document and make sure that our strip brightness configuration exists, and then we're going to update our configuration, which is the active config. And then we're going to close the file. During the save operation, it does the opposite, right? So we're actually putting our config in. This opens it for write. And the write operation doesn't have to do as many checks. We're just going to create that document with all of our properties. So we create with the delay speed, we create with the strip brightness, and we set the values with our whatever our current setting is. All right. Any questions on any of this code so far? That's all the changes.
Yeah, your document in this case is holding what you're going to pass in. right?
Yeah.
It's not gonna be waiting to flash every single time, it's just setting the code up for it. So when you feed that in, it's gonna change the settings on the fly, right?
Yeah, so anytime that you plug in, it's going to read from the configuration, whatever the current settings are. If it doesn't find anything, it'll use the default.
Right.
If it does find something, it's going to set those to whatever values it finds in that configuration file.
So-
Also, anytime you do a post request where you send in new settings, then it's going to call save config, and it's going to save out to flash whatever those new settings are.
But that's configuration of your brightness and your speed, not necessarily the message you're sending, right?
That's right. Just those two variables, that's it.
And when you get to the end of this demo, maybe you'll talk about how you're doing the independent for all of the different strips to form the letters.
Oh, well, that's a different library, different thing altogether, but I will show that demo, yes.
Okay.
Yeah. So the concepts are exactly the same. So if you're doing, later I'm going to show you my actual project was a LED sign where I had a text message, brightness, speed of the scroll, and the direction of the scroll. The scroll's left or the right. So I had 4 settings in that. And in addition to that, I also created configuration to save what Wi-Fi network I'm on, what the password was. I also set a configuration for the last step that I'm going to show is the authentication. So right now when we're making this request, I'm not requesting any username or password or no way to authenticate. So it knows that I'm an authorized user to change it. And so my configuration also contains that. And then the last thing that I added in that project was the ability to create, set this up as an access point itself. In which case, like I turn this on and I've got my home Wi-Fi or some other problem with my Wi-Fi SSID and password, that if it can't actually connect after a certain period of time, it falls back into an access point mode, and you can join the network that it's created so that you can then go update it dynamically. You don't have to reflash anything. And so that was, a lot more configuration, a lot more scenarios, but in order to show you guys the concepts,
Right.
I just wanted to show you one configuration with one controller, which is the strip. And that's why we're doing it like this. So same exact concepts I used to do my sign, but it was just more of them.
I guess what I was wondering is, like, you said so that they could change the message
Yeah.
of the sign. Every time they change that message, is that changing the config file and they're having to use their flash?
Yes.
Ah.
Yeah, every time they update the message, it would write that message into Flash.
You can't just go in and edit the config file and it'll just pick it up next time.
That's essentially what you're doing. But there's no just going in.
Until you turn it off and let it reconfigure, and every time you turn it off and turn it on, it's writing to your flash?
No, it reads from the Flash.
Oh, okay, so it's not using of your 10,000?
No,
Okay, that's
it's
what I
only
was wondering.
10,000 writes. And like these guys said, it's a minimum on the spec, right, for that Flash module.
Okay, thanks.
Yep. All right, so let me upload this.
Steve, the post that does write the file system, that's just a design decision.
That was my design decision,
You could
yes.
just as easily say, well, before you turn it off, you have to issue a command to
Yeah.
save it. But
Yeah.
then if it got accidentally unplugged, it wouldn't have the most recent.
Then it would have whatever the last time you saved. Yeah, absolutely. So it was my
Just wanted to clarify
design
that
decision.
It's not required,
Yeah,
but that's a decision you made so that the system is more robust.
that's right. Yeah. That way, if I update it and power goes out in the building and the power comes back on, I don't have to go do anything. It just comes back with
I keep the
the.
cable loose.
Yeah. Exactly.
Somebody else came in and changed the settings when he wasn't looking.
Somebody with a cell phone.
Somebody else logged
In that case, I just change the username and password so you could get them. All right. So now. So now you can see in the output, again, Wi-Fi stuff.
I'm in the computer room trying to set up my computer right now. You know.
Now we all grow beards.
Now we all grow beards while we upload it yet again.
Steve, which Arduino are you using? Is it an Uno or a Mega or a Teeny or what?
The 8266 breakout board has actually got its own MCU, so
Oh,
if you look here, you can configure this through the board manager for the Adafruit, Feather, Huzzah, ESP8266, and all the Adafruit 8266 boards, and a bunch of compatibles. But yeah, you set it up. It's got its.
Thank you, sir.
It's a 80 megahertz MCU in itself with 4 meg flash,
oh, I didn't know.
some I/O ports and other stuff.
So what can the Arduino do that this chip cannot do?
Nothing.
It's the other way around.
Yeah.
This can do a lot more than the Arduino can.
Much faster.
Even thought.
Steve, that's 4 mega flash, and how much of a RAM?
I don't remember on top of my head.
32 bytes.
It's more than 32 bytes of RAM, I'm sure.
Is it on the order of a meg or on the order of 256K?
It's on the order of a meg at least. It's a lot of RAM. Let's see. I think this will even tell me. It says 31K was used, which is 37%. So, as we can see, we've booted up successfully. We're running again. And so now I can update this. Once I find the right program, or someone else is going to do it for me.
Somebody else will beat you to it.
All right. So now you can see it's going much faster. And if I gracefully unplug it, put this back into serial mode. Now when I plug it back in, you'll see that we've successfully mounted our file system, we've loaded our configuration, and we've updated it, and again, it's going nice and fast and bright.
Pretty.
Yeah. So we now know that's working perfectly. All right. And then the last step is authentication. Let me show you what we did there.
This is authentication not for the server, but for the user.
This is for that client request to make the post request, to make the get request. Now you're going to have to be authenticated.
I've always had a problem.
Yeah. And to be clear, I am only going to show basic authentication. There are other modes that this supports, like digest and various other things. They're a lot more complicated. You actually need to understand how authentication works, and I'm not going that deep. So I'm just going to show you how to configure basic authentication. We set a username and a password, and you have to supply that in the request in an encoded header. And as long as you pass in the right username and password, then it'll accept the request. Otherwise, it'll reject it. So in order to support that, you have to add a couple new char arrays, so a username and password array. And I'm gonna fix this other thing right now. Forget.
Read what's on the screen.
All right, so The new authentication is going to be called admin, that's the user ID, and ESP8266, that's going to be our password. We don't really have to make any changes until we get down here. In the handler, I didn't do anything different in root. So the root handler still doesn't require authentication, but in order to update and call anything in the strip handler, the get or the post, requires server authentication. And so here, all we really have to do is add these lines of code where we're saying, hey, if not authenticated with this username and this password, then return this request authentication with a fail response. And up at the top of this file, because I select up at the top here, I added a couple more const chars, something called www realm, custom authentication realm, and a response whenever authentication fails. I want it to return this response. I did put in some links to do some better authentication, the digest authentication. So that's a link to the example. This changes, if you remember the original, maybe I'll just look at the root. The root syntax is very simple. You say server on, this path, go to that function. In the server on here where I'm adding this authentication, in order for me to put the authentication here versus in the handle root method at the beginning of it, because I could just put this code down there too, but this makes it a little cleaner. What I'm doing is using something called lambda syntax. I create a function right here on that server request. I'm going to execute this code inside this lambda function. And it's just a different syntax that makes it a little easier to read in the code. But if you're unfamiliar with like C, C++, you might not be familiar with the syntax. But this is just an example. You could just as easily leave it in this same format, very simple, server on with the thing, and put this exact code at the very beginning of the handle strip method. It does the same exact work.
So that lambda, that's so it's a C basically, right?
Yeah.
Okay.
Yeah. But this is basically just creating a little anonymous method here,
Yeah.
so that everything in this curly bracket to here
Yeah.
is going to be executed.
That's very similar to JavaScript, which is what.
Yeah.
But,
Exactly.
yeah. Okay.
Let's see here.
Language reuse.
Fix my bug again.
Huh. That's cool.
I fixed some other bug that I forgot about. This is just basically, anytime you're updating these things, you should be using string copy to update them appropriately. So when I created the username and the password, I created those as char buffers, and you need to copy that in using the string copy context, or str copy, in order to not do like buffer overruns. If you just create a char star, which is basically a constant char array, then if you change that and it goes past the original size of the string, then you'll actually cause buffer overrun and crashing and that kind of stuff. So this is the right way to update the strings. Let's see here. Add some default things if it wasn't found. So I should have added this originally. If you read the configuration and it doesn't actually find this key in the configuration, we're going to go ahead and configure it to use the default. So I added that in this version 5. I didn't backport that to version 4. But it has nothing to do with the authentication piece. And I think I just added some additional configuration, though, in here where we're actually now also persisting our new 2 properties, username and the password. And when we save it, when we load it, the same. So we just add those. Up at the top, we should see right here. Yeah, so I added those 2 into the config struct. All right, so let me load this. Save.
Ray, what are you whispering about up there?
Well,
I know.
I said we should have distracted you when the password and ID were up there.
Right now, he doesn't know how to set them with his phone. His phone won't be able to do it.
Unless he had Postman client on his phone. Or one like it.
Or something like it, yeah.
Surreptitiously called HTTP bot, by the way.
Because they have
It's
to be a
available on iOS.
JSON when you send
They
them.
have to be in the header. So I'll show you how to do that here in one moment.
HTTP bot.
So on a regular browser, there wouldn't be a way to put that in the URL to put the username and password in a regular browser?
No. You'd have to use the developer tools to add some header, an authorization header, and fill it in that way. So you can do it from a browser, but like the typical user would have no idea how to do that. And since we don't have any, I'm not doing anything where it's popping up an authentication request, which sometimes if you require authentication, the browser might pop up a UI and says, give me a username and a password. All right, so it's started back up. Now when I come over here to Postman, if I try to change this to speed 100 and slow it way down,
That's great.
this is going to fail because I'm not passing any authentication, right? We're requiring authentication, but it's telling us, say, authentication has failed because you didn't tell me, you didn't send those bits that I'm expecting. And so, and the same would be on a get. You know, I can't even just do a simple get because the get also requires, that strip method itself requires authentication. Now, in the code, where I had shown you up here where I have this, if I wanted to allow GET requests unauthenticated, but POST requests require authentication, you can do that by moving this code down into the, right here, for the POST request. So the GET wouldn't even check authentication, but the POST would. And so it's possible, depends on what you guys want to do with this, but it's easy to move that around and determine exactly which one requires authentication. So in order to add authentication, you go here to the headers, and we have to add, so a lot of times this won't even be here, but you have to add a new thing. What's the way to just add this?
I think it's under authorization.
Oh, you're right, thank you. On the wrong thing. Authorization, so you go to basic authentication, and then you type in these values, and when you update the request, that's going to add that header, and it's going to encode it in base 64 encoded header. So you can see headers just went up to 2, and now we've got your basic authentication. So it's going to pass in, every time I make this request now, it's going to pass this header with my authentication values. So when I come and I run the post now, or the GET request now, it should return and be successful. So we have authenticated and we got our values. And with the post, now I should also be able to go to the body and change this. And we still have the header in there, so that should start working now as well. And we're going much slower. All right, so that is the meat of the presentation for the ESP8266 and the Arduino code. The next thing I want to show you is from when you're creating a client. You know, you might want a mobile application, you might want a Windows application or something to actually go control your device. And you can query it and change the settings. In my case, I created the sign and I wanted a Windows application, just a little console utility that I could just update the sign anytime I wanted to change the message, change the brightness. Let's see if this thing comes up. So what I wanted to do is show you guys an example of how you would make a request from C#, a little console app. Very slow today. All right. So this is actually Visual Studio today. I'm going to close all these things.
So this is for somebody that doesn't want to just keep using Postman as their UI.
That's right. Yeah. This you can get away from Postman. So the one trick with doing this is because I'm using self-signed certs, .NET by default requires the certificates to be valid. So in the framework itself, it's trying to call is valid and check that certificate chain that it matches up to some trusted authority. So because we're using self-signed certs, I have to kind of bypass that check on my client. And it's a client-side setting. The client is what's doing it. But by default, Microsoft and .NET, they require it, and so you basically have to opt out by writing the code to do that. And I'll show you how that works. So basically, I'm just creating a couple variables here in my main. This is the IP address, and what was it? 101 something?
202,
101, 202?
202, 111.
202, 101.
Designated penetration tester.
That's right. And I'm using a library, so if you come here and if anyone's familiar with Visual Studio, there's a NuGet package manager. NuGet is basically the way that you can get all your different dependencies and things out there, libraries that are available for anyone to use. So I wanted to do some stuff with JSON, right? The same way that we're doing it in Postman, where we're creating the JSON request. And so there's a very common library called Newtonsoft JSON. So I use this package manager just to install this dependency. Once that's installed, then I can do something called JSON convert and serialize my request object. And I'm just, again, creating a very simple JSON object here and serializing it into JSON format in my request. And so this is the syntax to do that. I set my two variables, speed and brightness, and then I set the formatting to none. There's other formatting options, I suppose.
So it figures out the type of speed and brightness automatically?
Yeah.
And it's number, not string?
That's number because I'm just giving it a number. So there's, yeah, the pretty formatting and then none. And then I got a method that called send get request, and I've got another method called send post request. So I pass in the first parameter is my authentication. The second parameter is the IP address, and I've got a flag called verbose and a path. And so the path is strip. And on the post request, I'm actually passing in this object, the JSON object. When I make the GET request, I don't need to pass anything as far as the body. So let's look at the send GET request. Here we're just basically creating an HTTP client. This comes with the .NET framework. So there's nothing special you have to do HTTP. I am encoding my authorization into a byte array. And then I set up the client base address. I set up the headers with the application type, the request type that I'm wanting to talk to. And then I pass in that authorization value with the basic. So this is, I just wanted to kind of show you guys the syntax. So I'm not going to get in deep on all this, but basically this is how you would make the same request that we've been doing in Postman. If I pass yes or true for the verbose flag, then I'm going to do some console writes so that we can see what those values are. And then I've got this thing called never eat poison. And it's all squigglied and all this stuff. This is because I'm actually disabling the SSL certificate validation checks. And so if I scroll down to the bottom here, I have this method where basically I'm overriding the server certificate validation callback, and I'm just returning true. Every time you call this for validation, I'm just going to say, yeah, it's valid, even though it's not. You would never want to use this in production. Bad idea. You should always use production certs. So this is what it's doing. If I set this to true, then this would not even compile. It would just say no. So you could modify your code so that it's only used in your test environment, but in your production it's never useful. So the send GET request disables that validation, and then we call GET async, and we wait for the response. If our response comes back with a 200 OK, then it's going to follow this code path and print out that response. If it's anything else, like a 500 or a 404 not found, that's considered not successful. And then it's going to print out the status code for us. If any exception occurs during any of this code, then it's going to fall into this exception handler and just print out whatever the error was. The post request is very similar in how we set up the HTTP client with the IP address, the headers, and the authorization. We've got the same things with our verbose flag. And then here, we're looking at our request, and we're taking that as string content. And then we're going to pass that in to the post async. So we have our path, and we're passing in our content, which is that request that we've serialized, or take the JSON as a string, and we pass it in. And again, if it's successful, we print it out. So it's almost identical with that very small difference. So if I run this, like this, you should see it do a get and a post. So this first part here was the get, where we actually went out and read whatever the value was, and it was 100 and 255. And then on the post, we've updated it back to 0 and 150, so it's a little less bright, but much faster. All right. So, and that concludes the demo of the strip. So the next thing I'll show you is my project. We're not going to go do any kind of a code review on that. It's a lot more extensive. That's also not the code I'm sharing. This is the code I'm sharing. But I just wanted to show you this was the technique I used to do this from end to end, including all the file system authentication, secure.
Nice.
So, any questions on this, guys?
It's awesome.
All good?
Very good.
All right. So let me run this. All right, so don't judge me on my poor woodworking skills because I made a calculation error on the length. But this is basically two LED matrices that Adafruit sells. They're about $100 each, so it's a little pricey. Brady, who's a DMS and a DPRG member, he was doing this with actual individual strips, I think 8 individual strips that were this long.
Excuse me, Brady is in the building right now if you want to.
Oh, is he? Yeah. He was supposed to be here today to watch this, but see, watch the recording. But anyways, so I'm using this instead of the strips just because I was more interested in developing the Wi-Fi capabilities and the software part than the hardware thing that he was doing. Plus, I was able to just use Adafruit's matrix library. So in this example, I used the strip library. They have another library called .star matrix, and I was using that library. And that is one where you can just tell it, this is the message, and this is the position. And so while I'm not going to show you all that code, it's very easy. They've got examples online. I didn't do anything extra fancy other than what their samples show you how to do. So if you're interested in these things, to make your own sign using these same techniques, it's very easy to do. All right.
And the Arduino's in there as well?
Yeah, so I left this panel open so you can basically see what I did was I took a little Adafruit proto board and I put the same 2 chips that we used and a capacitor and my programming pins right there that are all exposed so that I could just do this exact same wiring configuration. It's nothing different. Yeah, that's basically what it is.
So you can bend those things that much that it's not going to hurt them?
Well, not repeatedly.
Oh,
Yeah.
10,000 times.
Yeah. I also added just a little power adapter here at the end so that it makes it easy. And then in this case, I just have a little wall wart. This is the 2 amp, 5 volts wall wart. And you can see,
Nice.
I don't know if you can read it.
Connecting.
Yeah, connecting. So let me, right now it says good morning. I'm gonna increase the brightness here in a second. So
Somebody does it for you first.
It tells me that wouldn't be so easy with this one. He's got the Dave Anderson filter in place already.
Requires authentication.
If username equals Anderson.
Right.
this actually probably has the same user ID and password. I don't know. All right, so sign app. So this basically is a more advanced version of the console app I just showed you doing the sample request. And so if you just hit,
Uppercase.
there we go. Oh, I'm spelling something wrong. Case shouldn't matter. Anyways, so this one actually has, I created a console parsing thing so I can have different verbs for each of the different things I wanted to interact with. So each of my handlers, I've got a sign handler, a Wi-Fi handler, a user handler, in order to modify those different configuration values. And so each one of these I can then just use the sign admin to update the sign. And then if I'm not sure how to use it, then I can get the help for it. And so this just shows you the different syntax that you need to actually operate this thing. And so if I say auth, so you can use -a or --auth.
So this has some persistence, so it knows the IP address?
You have to tell it the IP address.
Okay.
Right. And so right now I don't even know what the IP address is. We'll have to figure that part out.
It could display the address.
It could, and if I plug in the debugging cable, it would have it on the console outlet for me, but I don't have that set up yet. So I got another little network utility called Fing, F-I-N-G, and it'll just scan the network for this thing.
So
Oh, really?
you find it by its, what do you call that, the Wi-Fi name?
Yeah. I didn't think about this.
Thing works on somebody else's network.
Oh, yeah.
Oh, my.
Any Wi-Fi that you're connected to.
I had no idea. Huh.
Problem is, this one is very
Persnickety.
busy.
Who said that word? Persnickety?
Persnickety.
Actually fighting out in the parking lot over that or something?
I'll just keep it on this.
So the things we're seeing on the console there didn't come from the sign? Weren't being served by the sign, they were coming from where? The stuff that's being shown here.
This is the little console app that I wrote. So,
Okay, so it's on the PC, it's not, it didn't log onto the sign and get that information back
that's
to the
right.
sign?
Yeah, that's just
Okay.
I've heard that word.
code running on the PC.
Okay.
So let me actually plug this guy.
Get out your thesaurus.
Yeah, I've heard
My mother
Nice way to say it.
typically was used.
I think in an earlier version of my
What I
code,
was eating.
Yeah,
because it's easy to word history.
I did output the IP address for a while.
Straight to the display.
Yeah.
That's one of the-
That's the one benefit of having display with your project is they can tell you things.
Change the meaning of it.
Yeah, it means something bad. You can't say it anymore. You can't use that word.
Is that no longer for PC?
That's right.
It's not persnickety correct anymore.
Yes.
My mother used it in the context of someone who was being too picky, being too persnickety. And there's a certain snarl.
This works.
I've used that word since, I mean, I learned it as a young kid. It's
I hadn't heard that word in 50 years.
forever, yeah. It's a good word.
It is.
It's apt in so many
It's
cases.
a happening word.
Yeah.
There's a whole generation out there that doesn't know that word.
Yeah. Well, it's from last century.
They must have some millennial equivalent of that word.
Yeah. That's why I said, get out your thesaurus and see what it is today.
What's this?
They were so excited.
Remember what pin out is?
They were so excited they had discovered this new thing you could broadcast to. Yeah.
Sorry for the delay.
Sorry.
I'm trying to remember what the pinout is on this kind of thing.
It's okay, they're still stuck on persnickety.
All right.
I think they're selling.
Yeah. It's like 3D. It was, yeah, it was like, oh, this is the secret algorithm. You know, there's basically different. We can hear our stuff in half different.
That's probably
Yeah.
That's our.
There we go. Okay, so that loaded, and this is also showing you all, I'm dumping out all the configuration that I have in this device. So this has got the SSID, it's got the AP SSID and password, so if I do fall back, I have the wrong Wi-Fi information, it's going to fall back and create its own access point so that I can connect to it. It's a little tricky to do that, but it works. Then the admin ESP8266 is the authentication, user ID and password again. And then I've got the delay, brightness, message direction, all that kind of stuff. So this is the IP address, 192.201.255. So I have to pass in.
And that's hard-coded in there.
No.
It was assigned that when it logged in.
When I joined this network, it assigned me this IP address. And in this admin client doesn't know it either, so I have to tell it what IP address to use. The memory sucks, so I'll go back there.
201.255.
201.255. And so then I can pass or change any of the variables that I've got set so far. So, and it works in the same way as I described before. I can pass them all, or I can just pass one, in any one that I want. So in this case, I just want to increase the brightness. So I do -B, and I'll say 255, make it bright. Now this should go out and make the connection to my sign, authenticate, and update the brightness. I don't know, see it working or not.
Yeah.
Okay.
There we
There we
go.
go.
Yep.
Very bright.
Very bright. So I'll turn the brightness back down, let's say to 50. Yeah, so I'll blind you.
Yeah, now we got coffee,
And then maybe I want to change the direction. I can do -D, dash,
So it'll say morning good.
direction, right, yeah.
Score.
Ooh.
Go in the other direction.
Go more.
Basically, that's the demo. It was a very fun project, and I enjoyed doing it, so wanted to share the experience and share the techniques with you guys. I think that these particular techniques with the little cheap Wi-Fi chips like this, you guys might find useful on robots, where you want to actually query telemetry dynamically while your robots are running, or have it connect and be spewing stuff out. What we didn't talk about today was you can actually make outbound connections from the Wi-Fi chip. So it could be sitting there monitoring different I/O pins or whatever, and then sending it to something like Adafruit.io, and then building a nice dashboard or something, where you have your current speed and current pin values and current whatever things that you want to do. Like, I know, Dave, you've done quite a bit of telemetry work in your stuff, but you're having to query it and get that. You could push that out to a web service.
Tanner's has these?
I think you can ask them; they can get them if they don't have them. But they have a lot of Adafruit stuff.
They're just across the street.
Yeah.
You got about a half hour.
That's no way.
Yeah. Close at 3.
Yeah. So
Well, that's right, Sam.
yeah, just remember there are 3.3 logic on the ESP8266. So if you're comfortable with that, it's fine. Otherwise, if you're using sensors that require 5 volts, make sure you get a level shifter as well.
So you supplied it with 5-volt power, or you had to convert that to 3.3?
I supplied it with 5 volts because the strip wanted 5 volts. And so if you look at this board, yeah, it's got a little regulator. So I just supply it with 5, it drops it to 3.3. But this, I'm just passing through the 5 to all the different devices.
And one more question. you use the programming cable to upload the program. Is there any method, or do you think it would be possible to do a Wi-Fi
Yeah.
bootload, a Wi-Fi upload?
Yeah, it's called over-the-air updates. This chipset and the ESP32 support over-the-air programming and updates. So you do have to do some additional work to get it to work, but they've got samples out there exactly how to do that, yeah. So you could easily update firmware over the air.
And you can program them in MicroPython.
Yeah,
Oh,
he likes Python.
pretty versatile.
Dave, could you bring up
There's
the
a-
website?
There's a JavaScript environment you can load on these.
Oh, really?
Oh, yeah.
Sure enough, yeah, I grew up.
So you can run a subset of Node.js on it.
So you have two ESP boards on your display board?
I have just one here and one on this other demo.
Okay.
Yeah, I was just using one. Here, at the end of the presentation, after the demo, I'll bring this up.
So the whole matrix is still controlled by one SPI?
Yep. Yeah, just one SPI and two pins. Right now, I'm just using any 2 pins, but if you use hardware SPI, the maximum speed of the scroll would be faster. I'm not using the hardware SPI pins for no particular reason. Yeah. Here are all the parts that I used in the demo. So I've got a couple different level shifters. There's the 8-pin one I'm using on this board, but this sign just uses the 4-pin, or the 4-pin, 4-channel. And then the 2 different dot star strips that I used are listed there. Those guys have, I don't know, a dozen different dot star strips. And then here I've got some additional references for ESP8266, the core documentation for Arduino. This is, everything you want to know and more about the ESP8266 if you want to start working with it. The Arduino JSON libraries, very well documented, great examples. That's that site. And then the Adafruit dot star. This one is for both the matrix and the strip. There's a whole learning and tutorial on how to use those different LED things in order to do these kind of projects. So if you go to Adafruit's learning site, you can learn all about how to manipulate these LEDs.
Nice.
That is truly the end.
Thank you, Steve.